To design any lightweight structures, especially in Australia where the wind load dominates over earthquake in most of the areas, it's very important to understand how you calculate the wind pressure. So in this video, we're going to learn how to calculate the wind pressure that's acting on the surface of any building or structure using AS 1170 Part 2, the recent update 2021. We will also discuss on some of the updates which comes after 2021 has come into effect. So after this video, you will be able to find the basic wind pressure that you can apply on any structures and design that structure. It's very important for someone who is starting out in the field. So let's go. For designing any structure, we need to find the wind load acting on the structure. So in this case, let's find out the wind pressure that's acting on the surface of this wall. To find out this wind pressure that's acting on the surface of this building, we need to first find out where the building is located. Currently, our building is located in Perth, Western Australia. Now that we know where our structure is located, we will use this code AS1170 Part 2 2021 Structural Design Actions Part 2 Wind Actions to find out the design wind pressure. So to do that, firstly we need to find regional wind speed. To find regional wind speed, we need to understand this. Australia is divided into different wind regions. These are the northern, these are the southern regions, and this is the central regions. Based on that, we will find where our structure lies. So our structure lies in Perth here. So let's get rid of the other regions. So we now know our structure lies in that southern region. So now next thing is we need to find side wind speed. So let's say our side is here and then zoom in our side. So the side wind speed take into account the direction of the wind that's acting on the structure, the profile of the land, the roughness of the land, and the shielding. That is, if your building is behind a huge building that's blocking the wind acting on the acting on your structure. After you find out the side wind speed, you need to find the design wind pressure acting on the building. That will be defined by shape of your building. There's a factor called aerodynamic shape factor. So we will use that and factor, and then based on the shape of your building we will find the wind pressure. Yes, now that we have some concept about how to calculate design wind pressure, let's see how we can actually do that. So drag back below. So let's start with regional wind speed. Let's say our structure has a design working life of 50 years, importance level of 2, which you need to go to NCC and find out if your structure building has a large number contain a large number of people, then it will be importance level 3. For in our case, let it be 2. And then comes annual probability of accidents. It's the probability of wind occurring in this many years. So let's say it will occur once in 500 years. How do you know that? We go to NCC to check that. We know our importance level is 2, and then we know it's a non-cyclonic region. We will get into that later. So it's 1 in 500. Also, if you go to AS 1170 Part 0 with design working life 50 years, importance level 2, the annual probability of accidents is 1 in 500 for wind. Go here. Now you have your region. So go down. Our site lies here in Perth, so it's in region A1. And then for the design wind speed, regional wind speed, sorry, for the regional wind speed, we have our annual probability of accidents 1 in 500. Our region lies in A1, so it comes at 45 meter per second. So here, our structure lies in A1, so it's non-cyclonic. There are some changes in B2 you need to refer for which if your structure lies in B2 region, it comes into cyclonic now as per NCC. It's the recent updates. Now we have our regional wind speed. Next is the side wind speed. Now for the side wind speed, let's start with wind direction multiplier. It takes into account the direction of the wind that's hitting your structure. So we have different wind speed for different wind direction that's hitting your structure. In our case, let's take it as one. It's max. So next comes a climate change multiplier. It takes into account the probability of changes in the climate in future. So one is max, so take it as one. If you go to this table, this code, you'll find out. So now comes site exposure multiplier. So MZCAT, it takes into account the roughness of your area site. That is, if you have a tree, grass, or it's an open plain. Uh, as MS shielding, it takes into account whether your building is shielded. MT is a topographic multiplier. It takes into account the profile of your land, whether it's located on a hill or whether the structure is in a valley. So starting with terrain category, which is used to calculate MZCAT. So let's take into 2.5, which is open terrain, a grass of 1.5 to 5 meter. You need to go to this clause to find out the description of different terrain. So if I just show you, we have four different terrain categories. So let's take it for our case to be 2.5, sorry. And then go here. We need to find the average height of the building. That is uh, from the ground surface to the average height of the average height from the slope. So go here and then you will get a terrain height multiplier based on these formulas we use. So our terrain category is 2.5, and then we have the height to be 3.5, so which falls on 0.87. So go back and then our MZCAT is 0.87. Now shielding factor, take it as one. Usually we take it as one because you never know your shielding. If your building is behind a big building, and then if that big building demolishes, your shielding is gone. So you can't take that risk. So take it as one for now. And then topographic multiplier. It takes into account the shape of the hill, whether it's a valley or on a hill. Just take it as one for now to be conservative. Now we have side wind speed. We got all our values: regional wind speed, climate change, wind direction, topographic multiplier, terrain height multiplier, shielding. So plugging those values, we get 39. So based on that, now we got the side wind speed. Now we can find the design wind pressure. Design wind pressure is density of air. This one. VDES is design wind speed. Bit different to design wind side wind speed. This one is aerodynamic shape factor, C shape. C dynamic is a dynamic response factor. So let's find out first, starting with design wind. It's a density of air 1.2. So we now have to find VDES. VDES is the maximum of VSIT. VSIT we will have 8 different values for 8 different wind directions. So since we have taken as one, which is max, so our VDS will be equal to VSIT, and then that's this one. So design wind pressure. Now we have all our values, plug it in, and then we get our design wind pressure into C shape. That's aerodynamic shape factor. We take into account the shape of the building, and then C dynamic. C dynamic usually taken as one only for structure that are dynamically wind sensitive. We use the section 6 of AS1170, AS1170 part 2 to find that, but take it as 1 for most structure. So we got our basic wind speed of 0.92 kPa, which is kilonewton per meter square. And then you need to, you for different building and different shape and different structure, we will have different C shape. That is aerodynamic shape factor. So that's how you find the basic wind pressure, design wind pressure for a structure. Thank you.